The way that we calculate this is based on three factors. How much charge do you have? How fast is that charge moving? And what is the strength of that field? And then what component of that is perpendicular to that field? So the charge in coulombs, velocity, or the speed really in meters per second, and then the strength of the field in Tesla. The angle represents the angle between the velocity or the speed and the magnetic field. And I guess really with the direction, you have the velocity there. And the biggest thing is to keep an eye on how much is it perpendicular to the field. Is it if it's actually aligned with the field, there's no force, right? If it's perfectly aligned with it. But if it's at a 90-degree angle, you're going to have perfect amount of force. I'm going to have you try this one using the right-hand rule as well as calculating this. Let's say that we have a force exerted on a 3 microcoulomb charge, positive, moving north at 300,000 meters per second, and a magnetic field of 200 millitesla. And let's say that the field is directed north in part A, the field is directed south in part B, the field is directed east in C, and then west in D. And yeah, let's try that. So go ahead and pause the clip and work through all 4 of these, calculate each one, and then also use the right-hand rule, and let's see how you do. All right, so for part A, if this is moving north and the field is moving north, this would be sine of 0 degrees. There's no force. So the velocity is north, the field is north, no deflection. In B, if the particle is moving north, but the field is going south, this is 180 degrees. So again, sine of 180, this would be 0, so there's no force on it. In C, we would have, our pointer fingers pointing at the ceiling. Our middle finger is going to our right wall, and then our thumb is into the page or into the screen here. So the force would be down. In part D, we're pointing towards the ceiling. Our middle finger is going from right to left, and our thumb should be pointing at our face. So the force would be up. And then that amount of force in C would be 0.18 newtons into the page, or in D, it would be 0.18 newtons out of the page. How about this one? Let's say that our particle is at an angle to the field. This particle is going 300 meters per second, 300,000 meters per second at an angle of 34 degrees, and we want to figure out what the force is on the particle. And so on this one, you're going to calculate it, but also use your right-hand rule to see if you can figure out the direction of the force. And so go ahead and pause the clip and give this a try. And when you're ready to check, you can hit play to continue. Okay, so if we orient our hand, we should be pointing, kind of towards the top left, and then the field is going to the bottom left, and the force would be out of the page. Your thumb should be pointing at your face. And the amount of force would be 0.10 newtons. All right, so let's say we've got a proton going from west to east, and our field is coming out of the page. And we'll just practice this one. So go ahead and work this one out, and when you're ready to check, you can hit play to continue. All right, so what should be happening on this one is you should be pointing to the right wall. Your middle finger should be coming, actually, if you're holding your arm like this, you're pointing at your right wall, and then your middle finger is going to your back wall, so behind you, and then your thumb should be pointing at the floor, and the force would be down. First would be towards the bottom of the page, towards the floor. Now, what we have with the right-hand rule, with a negative charge, if our object is coming into let's say we have an electron, it's encountering the field and it's being forced. Yeah, we can figure out, what the direction of, or what the force is. And what we do is we pretend it's a proton, and use the right-hand rule, and then determine the force, or then when the force is opposite direction. Okay, So let's draw this first one out. Let's say we have an electron that's moving from left to right, and our field is going into the page. And we want to figure out what force it'll experience. And so we pretend like it's a proton. We figure out the direction of the force, and then the force is opposite for proton. So go ahead and pause the clip and try this one. Orient your hand to get that, and then when you're ready to check, you can hit play to continue. All right, so what will happen is you should be pointing towards your right wall. Your middle finger should be going into your screen, and the force on a proton would be towards the ceiling. However, it's an electron, so the force would be towards the floor. Let's go ahead and try this one. Let's say that an electron is going into the page, into your screen. The field is going towards the floor, and you want to determine the force on it. And so, yeah, go ahead and pause the clip and give this a try. And when you're ready to check, you can hit play to continue. All right, so to orient your hand, you should have pointed into the screen. Your middle finger should be going towards the floor. And a force on a proton would be to the left, but because this is an electron, the force would be to the right. Why don't you try this one? Let's say the field is going out of the page and proton is going to the right. So go ahead and try this one, and then when you're ready to check, you can hit play to continue. All right, so so you should point towards the wall. Your middle finger is coming towards, you're pointing towards the right wall. Your middle finger is going towards the back wall, and your thumb should be pointing downwards, so the force would be down on a proton.